Hello students, in last class we were discussing about vector. There we have seen what is the definition of vector, types of vectors. In today's class, let us see some more concepts on vector. That is, let us see what is direction cosines. Now if you see, here you have a position vector OP of a point B with the coordinates x, y and z. For this position vector OP, this position vector OP is making an alpha, beta and gamma angle with the positive direction of x, y and z axis respectively. That is, alpha, beta and gamma are the angle made by the position vector OP with the positive direction of x, y and z axis respectively. And this angles are called as directed angles. That is, the angle alpha, beta and gamma are called as directed angles. Okay, they are the angles made by the position vector with the positive direction of x, y and z axis. If they are called as directed angles, then the cosine of this angle, that is the cos of this angle, will be called as direction cosines. Okay, therefore cos alpha, cos beta and cos gamma, the cosine of the directed angles will be called as what? Direction cosines. They are called as direction cosines. This direction cosines will be also represented as L, M and N respectively. Okay, so they are also called as, we either call it as cos alpha or L, cos beta or M, cos gamma or N. Now let us see how to find what is the value of cos alpha. Now from the triangle, see here, actually see, this is the position vector, OP is the position vector. The angle made by this position vector with the positive direction of x-axis is alpha. Okay, so if you consider the triangle OAP, okay, if you consider the triangle OAP, actually it is a right angle triangle. Here on the board when I write, since it is not a 3D figure, okay, means we have taken a cuboid, but still when we write, you are not able to find whether it is a right angle triangle. But actually you get a right angle triangle. To be more clear, next what we do, beta is actually the angle made by the position vector with the positive direction of the y-axis. So when I consider the triangle O, B and P, there at least you can see this O, B and P. In this you can see it is a right angle triangle, at least in this. Similarly, you will be having a right angle triangle even when you take a triangle OAP. So when I consider the right angle triangle OAP, from this let us define what cos alpha is. We know that cos x or cos alpha will be equal to adjacent by hypotenuse. So cos alpha, the adjacent of this will be equal to, this is x, okay? The adjacent of this will be x by hypotenuse. Hypotenuse is nothing but vector r. So here when I take hypotenuse, I should not consider the vector, I should only consider the magnitude of it. So this will be equal to x divided by magnitude of vector r, which I have also told that the magnitude of vector r can also be represented as just r. So from this we have come to know that cos alpha, which is adjacent by hypotenuse, for the triangle OAP, the adjacent side is x and the hypotenuse side is r. Now, so cos alpha can also be written as x divided by r. Here one more thing, x divided by, how we write magnitude. Here we have taken the position vector OP and we know that position vector OP is equal to xi cap plus yj cap plus zk cap. So what will be the magnitude of this position vector? Magnitude of the position vector will be equal to root of x square plus y square plus z square. So this can also be written as root of x square plus y square plus z square. X divided by root of x square plus y square plus z square. Now next, Let us take the next triangle, that is the triangle OBP. Observe only this. OBP, and this is nothing but y units. Let us take this distance O to B, let us take that to be equal to y. From this triangle, right angled triangle, again we need to define what is cos beta. So let us define what is cos beta. Again it is adjacent by hypotenuse. For this will be the opposite side, this will be the adjacent side, and this will be your hypotenuse. Therefore, adjacent is y divided by its hypotenuse is r. Therefore, y divided by magnitude of vector r, which we can even write it as y by r, or y divided by what will be the magnitude of r, that is root of x square plus y square plus z square. You should remember why I am writing magnitude of r as root of x square plus y square, because when I told that the position vector OP can also be represented as vector r in our previous classroom. So similarly, let us find what is cos gamma. Let us take the right angle triangle OCP. So here if you see right angle triangle OC and P. From this triangle, clearly observe OCP. This is your right angle triangle. From the triangle, let us find what is cos gamma. So cos gamma will be equal to, again adjacent by hypotenuse. So this will be your adjacent side, which I take it as z. So the distance from that is O to C. The point O to C is z. Z divided by magnitude of r. Z divided by magnitude of r, which is z by r. Therefore, this is equal to z divided by. So magnitude of vector r can be written as how? Can be written as root of x square plus y square plus z square. These are the different forms of writing direction cosines. But you should understand how you got direction cosine. That previously we had directed angles. Those are alpha, beta and gamma. So cosine of those angles will be called as direction cosines. Cos alpha, cos beta, cos gamma, which can also be represented as L, N and N. Sometimes we even write it as, see, when I can write cos alpha as L. Cos alpha can also be written as x divided by root of x square plus y square plus z square, and cos beta can also be written as y by root of x square plus y square plus z square, and cos gamma can also be written as z by root of x square plus y square plus z square. Okay, understood? Now let us see what are direction ratios. So here if you see n can be written as x divided by r. From this I can write LR of e equal to x. Similarly, when you take n is equal to y by r, I can write n into r is equal to y. And similarly, when you take n is equal to z by r, I can write nr is equal to z. Okay, so these numbers LR, MR and NR, the numbers LR, MR and NR, okay, I call this to be equal to A, B and C. So these numbers which are proportional to direction cosines, those numbers are called as direction ratios. Means the numbers which are proportional to direction cosines, those numbers will be called as direction ratios. So if you take number A, they are telling that these numbers are actually proportional to what? Proportional to direction cosines. Direction cosines are L and N. So A by L, B by M, C by N are actually proportional. How they are proportional? How we can write A as? A can be written as LR by L, means A is LR, so divided by M. B is nothing but MR divided by M. C is nothing but NR divided by M. So if you see, they are actually proportional and are equal to R. Therefore, these numbers will be called as direction ratios. In simple words, if you see, when I write LR is equal to A, MR is equal to B, NR is equal to C. If you can observe, again, LR is equal to X, MR is equal to Y, and NR is equal to Z. So, in simple words, I can say that is the coordinates of the point P itself will be the direction ratios. So, I can say X, Y, Z are the direction ratios of the point P. Okay, for the position vector OP, what will be the direction ratios then? For the position vector OP, the direction ratios will be X, Y, and Z. So, if you have the position vector OP, which is in the form of xi cap plus yj cap plus zk cap, then if we are asked to find what is the direction ratios, then the direction ratios will be simply x, y, and z. Then what would be the direction cosines? The direction cosines will be x divided by root of x square plus y square plus z square, y divided by root of x square plus y square plus z square, and z divided by root of x square plus y square plus z square. So here I should write what will be the direction cosines and direction ratios. So for the vector R or the position vector OP, which is xi cap plus yj cap plus zk cap, simply I can write the direction ratios will be nothing but x, y, and z. And the direction cosines they ask, then the direction cosines, either you can represent it as cos alpha. I have given all the representation for direction cosine. So cos alpha, which will be equal to this x divided by magnitude of this vector R, which is root of x square plus y square plus z square. Then cos beta will be equal to y divided by root of x square plus y square plus z square, and cos gamma, which is z divided by root of x square plus y square plus z square. So in your questions, when they ask, when a vector is given and they ask you to find what is its direction cosines and direction ratios, just by taking the coordinates, that is the coefficients of I, j, k, if you write the coefficients of I, j, k, that will be your direction ratios. And for direction cosines, if you simply apply this formula, then you get the direction cosines. Next, let us see addition of vectors. That is how we can add any two vectors. In this, we will be studying two laws. One is triangular law of vector addition, and the other one is parallelogram law of vector addition. First, let us take up what is triangular law of vector addition. So this says that if two vectors are taken as two adjacent sides of a triangle taken in an order then the sum of the two vectors will be represented by the third side taken in the reverse order. Let us try to understand this. Okay. So first thing, here we use the concept of free vectors. If you remember, after we discussed what are the types of vectors, I told what free vectors are. Free vectors are those vectors which are subjected to the parallel displacement without changing its magnitude and direction. So if you have any two vectors, if this is vector A and you have got one more vector which is vector B, I can displace this vector parallelly without actually changing its magnitude and vector. So this vectors, I am going to display a vector B without changing its magnitude and direction. Okay. So after this, so if you see here, I consider if two vectors are taken as two adjacent sides of the triangle taken in an order. So I am taking as two adjacent sides. So this one side and another side taken in an order means one where the first vector is getting ended up, the second vector actually starting up. So we are taking in one order. Taken in an order, then the sum of the two vectors, the sum of these two vectors will be represented by the third side. So this will be the third side of the triangle, but how? Taken in the reverse order. So this was the order which we are following. Now I should take it in the reverse order, means my order should be in this pattern. If I take it in the same order, then my order actually should be in this form. But they have asked us to take in the reverse order. So this will represent the addition of two vectors. Okay. So what we did, we have taken two vectors as an adjacent side of a triangle in one order. Then the sum of these two vectors will be represented by the third side of the triangle, but in a reverse order. So let us see what happens if we take in the same order. Actually, we told that when I take OA, vector OA plus vector OB will be equal to vector, let us take this as ABC only. So this is ABC. Okay, so I write vector AB plus vector BC. I told this will be equal to vector AC. Okay, so vector AB plus vector BC should be equal to vector AC. Remember students, starting point is A, terminal point is B. A to B, then starting point is B, terminal point is C, B to C. Here our direction is in this format. So starting point is A, ending point is C. In case if I take it in the same order, what happens? So vector AB plus vector BC plus vector CA will be actually equal to 0 if I take it. How? See here, vector AB plus vector BC is actually what? Vector AC according to the triangular law of vector addition. So this plus CA, which is equal to 0. Now see, AC is nothing but the negative vector of CA. So CA can be written as minus AC. So if I just change the direction of this, I'll get a negative vector, same magnitude but opposite direction. Such vectors are called as negative vectors. So this will be equal to 0. There will be no sum. We can't add. So when you are taking, when you are adding two vectors, you should take it in this format only. Okay. So this is the addition of two vectors. Now how to find the difference of two vectors? It is again the same way. So I take vector A here. Next, what I do is the same vector B I take, but in the opposite direction. When I take in the opposite direction, so this will be minus B, same magnitude but opposite direction. Again here what we do, we apply triangular law of vector addition. So here we have considered two vectors and those two vectors are taken as the two adjacent sides of the triangle, and again in one order, then the third side of the triangle will be represented as the sum of the vectors, but you should take it in an opposite direction. So this becomes vector A plus of minus B vector. So that is nothing but A minus B vector. Okay, the same as addition of two vectors. This is triangular law of vector addition. So let us see what is. I hope you have understood. So when you have two vectors, so this will be the third vector, vector A plus vector B. Now let us see what is parallelogram law of vector addition. So in this only, now let us see what this parallelogram law of vector addition says. If two vectors are taken as two adjacent sides of the parallelogram, then the sum of the two vectors will be represented by the diagonal of the parallelogram passing through the common point. Okay, let us understand. If two vectors are taken as the two adjacent sides of the parallelogram. So let us consider this is vector A and you have one more vector, vector B. So these two vectors are taken as two adjacent sides of a parallelogram. But here they have not given any condition as in your triangular law of vector addition, that in triangular law of vector addition we have taken in one order. But here I have not considered any order. Okay, so these two vectors are taken as two adjacent sides of a parallelogram. Then the sum of the two vectors, these two vectors will be represented by a diagonal, okay, of the parallelogram. The condition here is this diagonal is actually passing through what? A common point. So the common point for these two vectors is this one. So the sum of these two will be represented by the diagonal passing through the common point. Therefore, this will be the addition of two vectors by using parallelogram law of vector addition. So if you see in a parallelogram, we know that the opposite sides are equal. So this will be your vector B, this will be your vector A. We say that triangular law of vector addition is equivalent to parallelogram law of vector addition is equivalent to triangular law of vector addition. Why? Because see here, in parallelogram we know that opposite sides are equal. So this vector B, here also this will be vector B. Here if this is vector A, this side also will be a vector A. Now if you observe, take off only the lower triangle. When you take only the lower triangle, this is a resultant of nothing but triangular law of vector addition. So you have vector A, vector B, which is taken in one order. The sum of these two vectors is represented by the third side of the triangle taken in the reverse order. So we can say that the parallelogram law of vector addition is equivalent to triangular law of vector addition. Keep in mind, we always use this law in order to add any two vectors. Next, let us see what are the properties of vector addition. Here, let us first take up the first property, which is commutative property. So, for any two vectors, vector A and vector B, the commutative property satisfies. That is, vector A plus vector B is same as vector B plus vector A. Next, at the associative property, That is, for any three vectors, vector A, vector B and vector C, the associative property satisfied, that is, vector A plus vector B plus vector C is equal to vector A plus vector B plus vector C. Next is additive identity. Additive identity means when I take a vector, any vector, let us call that vector B is vector A. If I add that vector to any other vector, I should get back the same vector, that is vector A. Such vector will be called as additive identity. Now let us think. You have a vector A, I should add one vector. When I add that vector to vector A, I should again get back vector A itself. So what will be that vector? That will be definitely a zero vector or null vector. When I add zero vector to any vector, I get back the same vector. So zero vector will be called as additive identity. Okay. Next is additive inverse. So you have vector A, you should add a vector so that it will give us a zero vector. So it is easy. So if I add with minus a vector, definitely I get a zero vector. So minus a vector will be called as additive inverse. Next, let us see what is multiplication of a vector with a scalar. Multiplication of a vector by a scalar. So what happens if I multiply a vector? Let us consider, let A be a vector. If I multiply this vector by a scalar called as lambda. Lambda represents any scalar. Scalar is that quantity which has got only magnitude but not direction. So if I multiply this vector by a scalar, which we actually represent it as lambda times vector A. This is called as multiplication of a vector by a scalar. What happens? Definitely this will be a vector. When we multiply a vector by a scalar, again the resultant will be a vector. So I'll give you an example. So let us take this to be as vector A. Okay, if I multiply this by any other scalar, so if I write it as 2 times of vector A, means for this I am multiplying by 2. So this will be equal to what? 2 times of this one. So this is vector A, 2 times of this vector A is this one. Okay, if I multiply by half of vector A, then what happens? This will be only so much. Okay, so you can see when we multiply vector by a scalar, its magnitude gets changed, but not direction. But when does its direction changes? When you multiply a negative scalar to it, then the direction of the vector changes. That is, if this vector is multiplied by, say, minus a, then what happens? This will be the same magnitude but opposite in direction. So one more resultant I should show you. When we multiply a vector, okay, then this by a scalar, then that will be a vector but collinear to the given vector. So here you have vector, I have multiplied it by a scalar. These two vectors, if you see, they are collinear. If you remember the definition of the collinear vectors, there we have said two vectors are said to be collinear if and only if they are parallel to the same line. So if you see, they are parallel to the same line. So if I represent this to be as vector B, Okay, so I can write vector A is equal to 1 by 2 times vector B, or vector A is equal to 1 by 2 is any scalar lambda times vector B. So if I say that the two vectors are parallel, then we can apply the condition, that is vector A is lambda times vector B. Remember this result. If we say that the two vectors are parallel, we can take this. How we got this? Through this example. Okay, vector A is lambda times vector B. It is understood that vector A is collinear to vector B, or vector A is parallel to vector B. Okay, here let us see what is vector joining two points. How to find the vector joining two points. Previously, if you remember, we have studied position vector. That is, if we have any point P with the coordinate x, y, z, then we wrote the position vector taking its initial point as origin. So any vector whose initial point is origin will be called as position vectors. So for this we wrote it as position vector OP is equal to xi cap plus yj cap plus zj. But here we need to find what is the position vector of PQ. So if P and Q are the 2 points with the coordinates x1, y1, z1 and x2, y2, z2, then the vector joining PQ, that is P to Q, will be given by what? Let us see. So here, if you observe, OP is a position vector, Y is a position vector, the initial point of the vector OP is at origin. So let us first write what is OP. So OP vector can be written as what? Xi cap plus y, x1 I cap plus y1 j cap plus z1 k cap. This we have already studied how to find. Next, for the point Q, again OQ is a position vector because again its initial point is origin. So for the point Q, let us write in vector form. So OQ vector can be written as what? X2 I cap plus Y2 j cap plus Z2 k cap, because the coordinates of the point Q are X2, Y2 and Z2. But we need to find what is the vector PQ. Vector PQ, the vector joining the 2 points. Previously it was only for 1 point. Now we need to find it for 2 points. Now here I am going to apply triangular law of vector addition. So if you see, OP plus PQ are the 2 vectors which are representing the 2 adjacent sides of a triangle taken in an order. Then the third side of the triangle will represent the sum of the 2 vectors taken in a reverse order. So from the triangular law of vector addition, from the triangle OPQ, I can write vector OP plus vector OP plus vector PQ can be written as vector OQ. Is it clear for you? So, from this I can write vector PQ is nothing but vector OQ minus vector OP. Okay? So, let us see how to write in a component form. So, vector PQ will be equal to vector OQ. What is your vector OQ? It is x2 I cap plus y2 j cap plus z2 k cap minus vector OP you have. Vector OP is x1 I cap plus y1 j cap plus z1 k cap. Let us simplify this. Therefore, if you simplify x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap minus y1 j cap minus z1 k cap. So, if you simplify, so here this will be equal to x2 minus x1 I cap. Okay. Next, plus of y2 minus y1 j cap plus z2 minus z1 k cap. So this will be the vector joining 2 points, any 2 points. Vector joining any 2 points can be written in this format. Then, what will be the magnitude of the vector joining 2 points? The same thing. So, magnitude of the vector PQ will be equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Understood? So, when they have given any 2 points, then they have asked us to find what is the vector. For example, if they have given a point A is equal to 2, 3, 4, point B is equal to 1, 0, 6. This is an example. Then if they ask us to find what is the vector joining these 2 points. If I need to find what is the vector joining these 2 points, vector AB, first I need to write its position vector. So how to write a position vector? So vector OA will be equal to what? 2i cap plus 3j cap plus 4k cap. And vector OB will be equal to what? 1i plus, you can write 0j plus 6k cap. Then what will be vector AB? That is vector OB minus vector OA. If you simplify, then you will get what is vector AB. This is how you find for vector joining 2 points. You should remember this formula. That is, vector joining 2 points will be given by x2 minus x1 cap plus y2 minus y1 j cap plus z2 minus z1 j cap. And the magnitude of the vector joining 2 points will be given by root of x2 minus x1 whole square plus y2 minus y1 whole square and plus z2 minus z1 the whole square.